Cool. So here you use some extra space to solve this. Now tell me one thing, that the extra space that you have used, why you have used it. I mean, let me ask you one simple question, that why did not you do something like this, that if you saw here, let's say array of 0 was 1, then why did not you make this transformation here itself, that array of 1 becomes equals to 0? I mean, instead of putting 0 at the second index of temporary array, why did not you change this element itself to 0? I mean, why not to apply the transformation in the original array itself? What can go wrong if I start doing that? Most important thing is that the original values will get overridden. If you have converted this 3 to 0, now when you come from here to here, you will not be able to see that array of 1 is 3. Rather, you will see that array of 1 is 0. So you will not be able to get the exact job done. So this is the problem with this particular thing. Yeah, correct. So that was the reason I used extra array. Now let's just try to understand that, yeah, one more thing. Can it ever happen that the temporary array that I am building in the current approach, in that temporary also values are getting overridden? Can it ever happen? That is not possible. Why it is not possible? Because you are doing temp of array I equals to I, and since I have told you that this array contains all the distinct elements, so all the value of array i's will be different. So a particular index will be touched only one time. It will never ever happen that a particular index of temp, let's say this index, is being touched multiple times, because the values at different indices in the original array are actually different. You should understand each part of it before moving ahead. This is an important question, by the way. Yeah, so now I want you to optimize on the space. Now I want that you should somehow solve this problem with order 1 space. We can store 2 values at index, yeah, that is a well-known popular approach, but I don't want to hear this approach because this approach is not that efficient. Why not that efficient? Because this will fail under circumstances. Swap values. Okay, somebody is saying swap values. I think I tried doing that. If you are swapping the values, then you might not end up doing justice, because if let's say you saw that array of 0 was 1, okay, and then what you are trying to say is that when you place 0 over here, you would place 3 over here. If you are saying that, then where will this 1 go? Where would you want to put this 1? So this is also not the right thing, okay. Try to thinking of it in this way, that can you somehow ensure that when you are placing an element at its deserving location, then the element which is getting overridden, before it gets overridden, it is placed at its particular deserving location. Can we do that? So this is the approach that I am trying to say. Now I'll just try to illustrate it. So let's say my original array was like this: 1, 3, 0, 2. Now everyone keep looking over here, just keep looking. So here you saw that array of 0 was 1, okay. So you would want to make array of 1, which is this index, as 0. So you would want that here value 0 should come. But before overriding this thing, what will you do? You will see that array of 1 is 3. Since array of 1 is 3, so you would want to convert array of 3 as 1. So you would want to convert this thing as 1. Now before you convert this thing, you can save its value in a temporary variable, and you see here that array of 3 is 2. So you would want to make array of 2 as 3. Okay. Now again, when you are here, you see that array of 2 is 0. So you would want to make array of 0 as 2, this thing as 2. So see, if you apply these transformations, what will happen? That 2 will come over here, and 0 came over here, and 3 came over here, and 1 came over here, and your job got done. So basically there was a cycle which started from this point and ended at this point. And can you write a code to execute this cycle? It won't be very tough, guys. It will be easy, because what you have to do is before you are overriding the value over here, so let's say you want to put a 0 over here, okay? Before you put a 0 over here, you store this value in a temporary variable. After that, you put this 0 over here, okay? And after doing that, immediately start placing this temp equals to 3 at its deserving location. And then do the same thing over here. I mean, before you override a value, store that value in a temporary variable so that it can be transported at its deserving location. And you keep doing this on and on till you reach the same index from where you started. So it won't be that hard. It might look to begin with a bit hard, but it is not hard. It is a very simple implementation thing which people do in their first year also. I mean, this is as simple as that. You just have to, so you have done this, so you know that before overriding a value, that value is to be stored in a temporary variable and then it is to be transported at its deserving location. And you know when to terminate. When to terminate? When you when the cycle is running and you ended up arriving at the same index from where you began, then your job is done. Okay, now tell me one thing. Yeah, so will this approach always work, or can it have some kind of problems? Can there be multiple cycles? In this case, there was just one cycle that touched all the elements, isn't it? In this case, there was just one cycle that touched all the elements, right? Is it necessary that there will always be just one cycle that touches all the elements? Think and tell me. It is not necessary. Even though every element is unique, it is not necessary at all. So let us take an example. So if my original array contained 6 integers and looked like 2, 0, 1, 4, 5, 3. Do some work on pen and paper and then tell me how many cycles are here. So if you take a close look, there will be 2 cycles over here. Okay, so let's say array of 0 is 2, so array of 2, which is this, should be made 0. Array of 2 is 1, so array of 1 should be made 2. Okay, and array of 1 is 0, so array of 0 should be made 1. So this is one cycle. Now when you come over here, then you see that array of 3 is 4, so array of 3 is 4, so array of 4, which is this, should be made 3. Now array of 4 is 5, so array of 5, which is this, should be made 4. And now here you see that array of 5 is 3, so array of 3, which is this, should be made 5. Okay, so this is cycle 1 and this is cycle 2. Now the problem with this thing is that, let's say an input array was given to you that contained elements like A0, A1, A2, A3, A4, A5, A6 and so on and on and on. Then it might be possible that there was a cycle that started from A0, touched this, and let's say came back to this. So this cycle, I am calling this cycle as cycle 1, this touched this element, and this element. Okay, now basically what you are doing, you are iterating over the original array. Okay, so when you iterate and move on, how will you identify whether this element was a part of previous cycle or not? Will you be able to identify whether a new element was a part of previous cycle or not? Will you be able to do that? You will not be able to do that, right? So are you getting it what I am trying to say? So whenever you move on to a new element, you will not be able to identify whether it was a part of previous cycle or not. So let's say you are iterating, and when you come over here, you would want to start a new cycle from here, because this might not be at its deserving location. But when you iterate and come over here, you would simply want to ignore this. When you come here, then you would again want to start a cycle. When you come here, then you would want to ignore it, because the elements that were part of some cycle, they need not be touched again, because if you touch them again, then you would end up spoiling their order. Guys, are you getting this point, what I'm trying to say? That the elements that were part of a particular cycle, they should not be touched again. So there has to be a way through which I end up not touching it again. What can be the easiest way through which I can ensure whether a particular index was a part of previous cycle or not? How can I do that? Extra space to store them, right? So I can simply have a Boolean array It could be integer array of ones and zeros also, okay, and I call that array as visited array. So whenever a cycle is being made, so initially in this visited array, all values are 0. All values are 0, denoting that none of these indices have been touched. Now whenever a cycle is executed, all those elements that participated in that cycle, their index will be made 1. So the index of this will be 1, index of this will be 1, and index of this will be 1. Now while you are iterating, you come to this element, you see that the index over here is 0, so there is a need to start a new cycle from here. But when over iterating you come over here, you will see that hey, this value is 1, so this was already part of some other cycle, so I don't need to touch it again. So this way you will be able to achieve your target. So this is an easy way to get it done. But what is the problem with this approach? As most of you are saying, that there is an extra space again. To store whether the elements are visited or not, I need an extra space again, and so if at all I am using an extra space of size n here again, why not use the previous approach, because that was way more simple, isn't it? That was way more simple. So this approach is nothing too good about it, right? So how can I get help over here? So there is a very important technique over here, all of you should remember. So one way to identify whether you touched a particular thing or not was via this kind of technique. Another technique is that whenever you are touching an element, convert that element into something which is different from all other elements. Okay, convert that element into something which is different from all other elements. So one way to do that could be, whenever you are placing an element over here, let's say the value over here was 5, okay, then instead of placing 5 over here, place something like -5, okay. Let's say you are placing over here 1, instead of placing 1, place -1. Let's say you are placing 2 here, instead of placing 2, place -2. So what will happen, that the indices that were touched, that would contain negative values, okay. So while performing your iteration, whenever you see that the element is non-negative, that means a cycle has to start from here. This was not a part of previous cycle. But if the value over here is negative, then you can simply ignore that element and move ahead. So I was saying that here, let's say you saw that array of 0 was 2, then instead of putting 0 over here, even if you try to put -0, minus of 0 will be 0 only. So is there a way for you to distinguish 0 and -0? Simple fix is that instead of placing the element over there, what you can do is, let's say you are trying to place value x, instead of placing -x, you place minus of x plus 1. So this will take care of thing, that instead of placing 0, you are placing minus of 0 plus 1, which is 1. So this way you will be able to take care of 0 thing also. So this is one way which will make your life easy, and this is how you will get your job done. Only thing is that when you have performed this iteration, when you have touched all the elements and successfully placed them at their deserving locations, then eventually you would want to transform back the elements, right? And how would you transform back the elements? How can you do that? So what is it that you have done? Instead of placing x, what did you do? You first did x plus 1, and then you multiplied this value by -1, and then you placed it at some index. So when you are done with this array, then you would want a way to come back from this to this. So let's say you wanted to place 5. So first you added 1 to 5, and then you multiplied -1 to it and placed -6. Now when you have to come back, so what you can do is, for array of I, you need to do two things. First thing is to multiply -1 to it, okay, and then you will get this, and then the last way would be to subtract 1 from it, okay. So when you are done with this iteration, then all the elements of your array would be negative non-zero numbers. Now to change them to their expected thing, you would want to reverse this, what you have done. So that is simple. Array of I should be transformed to something like this. That is, first you need to multiply array of I to -1, okay, and then you need to subtract 1 that you had added. So this way you will be able to gain back the expected array. This is a very, very handy technique, helps a lot. What are list of such reversible transformations? So there's no unique list as such. It's more of a common sense kind of thing. As some of you said that instead of placing x as this, I could also have placed x plus n, isn't it? In this way, I simply needed to check that if a particular element is greater than equals to n, then this is because this transformation was applied, and this transformation was applied because this was part of some cycle. So it was already touched, I need not touch it again. So in this case, the backward transformation would just be array I equals to what? Array I minus n. So it's totally up to you. I mean, which one do you want to use, which one suits you the best, and you can just simply apply that. The most important thing over here is that instead of using a visited array kind of thing to mark which all things are visited, a simple technique is to transform the things that you had touched such that you can recognize it later whether you had touched it or not. Okay, so if in any question this kind of thing is applicable, you must do that. And when we study some topics like graphs and all, we'll see that these kind of things come in very, very handy. Okay, because in graph also there are certain nodes. Okay, there are certain nodes, and then you don't know which node you have visited or not. Okay, so one way to track which nodes have been visited is by using this kind of visited array for all the nodes. Another way is to transform the structure of node in some way so that you recognize it whether it was visited or not. Okay, yeah, let us discuss about the complexities first, then I will help you with pointers to code. Time complexity will simply be order of n. Why order of n? Because any element is being touched how many times? Any element is being touched just one time. Okay, if it was already touched, then it is being ignored. And what will be the space complexity? Space complexity will simply be order 1 because I did not use any extra space. Okay, so this way you can get your job done. So always start your implementation with the things fixed in your mind such that you can take appropriate number of variables and change them in the right manner. So I am going to use the current approach where instead of placing x, I am placing negative of x plus 1. Okay, so let's say I am iterating over the array. So let me do that for I equals to 0, I lesser than n, where n is the size of array I plus plus. Okay, first I should check whether an element can be ignored or not. And how do I check that whether an element can be ignored or not? If an element was a part of previous cycle, then the value at array I should be negative. So if I see that array I is negative, I can simply ignore and just move ahead. So can I write this code that if array of I is negative, then simply continue. Don't do anything, simply continue on to the next iteration. Can I write this? Is this clear to everyone? So this is a very simple thing, right? In the else part, yeah, so what happens in the else part? Let's say the value at a0 was already some negative thing, let's say -7. That means it was part of some cycle. Now you came at a of 1 and here you have a value like 6. So there will be a cycle now that will start from a1, and maybe you see that a of 1 is 6. So you would want to change a of 6 as 1. So from here this cycle will go here, and from here again it can go anywhere and come back and so on, it will go on. So one thing that I can easily do is that what you should understand over here is that let's say you started your cycle at this index. Let's say this is the index 1 from where the cycle is going to start. Now whatever is the value over here, what is the value over here? 6. That is the index where you have to go, right? Whatever is the value over here, that is the index where you have to go, because this is what the question says. If array of I is j, then array of j should be I. And what is this j? This j is array of I, which is value at this position. So what I can do is I can have an index variable, and this index variable basically says the index where I have to go. So it can be equal to array of I. Okay, and is at this particular index, which is at index number 6, I have to place a new value, right? Can you tell me what should this new value be which I have to place over there? It should simply be I, right? It should simply be I, right? Now I have this thing. Cool. So now what I can do is, now I definitely need to write a while loop kind of thing, while loop or for loop, whatever you want, with certain condition inside it which performs the replacement of element, but before replacement it saves that element so that it can be replaced with its counterpart. Okay, so yeah, what should be the condition that I should have over here? Can somebody tell me? See, this index always tells me the index where I have to move from current index. Okay, so let's say you went from here, and let's say at this point of time the value of index became equals to I. So whenever value of index becomes equals to I, which is this, can I say that my cycle is going to get over? So can I have a condition that as long as my index where I have to go to is not equals to I can just keep doing my job, right? And what is the job that I am doing? First thing, I need to replace this. I need to replace this by this value, but before replacing I need to save it. So to save it, I can have a temporary variable, and in temporary variable I can store the value array of index. Okay, now after storing this, what I can do, I can change this value. Now I can change this value into this thing, which is val. Okay, after doing this thing, I need to update these two things as per this, isn't it? So what should I update first? How do I update my val and index? So basically, if you came over here, the index of this is 6, which was stored in this. So wherever you have to go from there the value that will go is 6. So what I can do is value equals to index. Okay, and after this I need to change the index also, right? What should be the new value of index? Whatever was the old value over here. And what was the old value over here? It was temp. So I can assign this thing to temp. Okay, now before having done these all things, one thing is important, that instead of placing val, I was placing negative of val plus 1. So this is what I will do. It's simple. Index not equals to I is very simple. What is index? At any point of time, your index is equal to that index where you have to jump. Okay, so let's say you came at a particular value such that the value of index became equal to 1. That means wherever you started from, you are coming back to that point, right? So you can simply terminate over there. One more thing to be kept in mind, that all this replacement would have done, this replacement would have got done, this replacement also would have got done, but this replacement would be pending, right? Because the loop broke over here. Because the loop broke for this point, so this replacement would be pending. Yeah, so that last replacement would be pending. So what do I do for that? Can I simply do that immediately after the while loop? Yeah, immediately after while loop I can have a single line of code which does that. So what I can do is, definitely the loop broke when index and I both values are same, so I can assign array of I or index, whatever you write, doesn't matter, equals to whatever value should come over here, which is stored in val. And basically instead of val, I would want this thing. So it should be consistent. I should place negative of val plus 1. Yeah, so when this much of code is written, you would already have got your job done. So I don't want you to again directly copy paste my code. Please do not do that. Okay, I just wrote it for your reference. Try your own logic. Okay, which is very consistent with the algorithm. And is just this much, or is there one last thing also that I need to do? There is one final thing that I need to do. I need to change the elements to their original value, because instead of placing x, I placed negative of x plus 1. Yeah, so I need to change them back to their original value.